will introduce two submission papers finished during my first years working. The first one is related to zero-shot learning. During the recent years, some papers turned to design extra part detector or attention models, trying to improve visual to semantic mapping through this way. Typically those methods have complex architecture and need more computation resource. While our proposed pipeline has the most compact structure and automatically achieve the attribute localization implicitly. This is our proposed method. It only contains two learnable parts, a feature extractor and an embedding, projecting layer. The attribute matrix provided by the dataset is fixed as a fully connected layer. We use the cross-entropy loss as the objective function. The spatial aggregation here is the pooling operation. Upper there is the global average pooling, down there is the global average pooling or global max pooling. They capture different range of information from the visual features. We will only use the second architecture. We visualize several channels of the visual features produced by the one-by-one embedding convolutional layer. Those features maps will correspond to the specific attribute in the attribute vector. It is obvious that GMP generates more fine activation than GAP, since it covers less spatial information. Down here is the visualization of the embedded vector after the pooling operation. The GMP will produce sparser representation, which is more resembling the attribute vector shown below. We compare the proposed pipeline with the related SOTA methods. In most cases, our extremely simple pipeline with GMP gets the highest performance. This simple pipeline should be a new pipeline in zero-shot learning, and it can be combined with plenty of existing generative methods, since in some degree it achieves attribute disentangled representation. For some attributes with low attribute value, the attribute localization is not accurate. We need to find a way to improve this. Here I introduce our NUR-IPS 2020 submission paper. It investigates a new setting of unsupervised domain adaptation problem. Unsupervised domain adaptation aims to transfer the knowledge learned from labeled source domain to unlabeled target domain. Here is the typical paradigm of unsupervised domain adaptation. The objective function contains a classification loss and an adaptative loss. The existing UDA methods demand labeled source data all the time. It is unfeasible when concerned with data privacy and computation capacity. Therefore, we propose a new setting called source-blind unsupervised domain adaptation, where the model is first trained with labeled source data and hereafter it has no access to source data. After we get the source training model, we freeze the classifier head of the model as a prior knowledge for source feature distribution. We train an extra classifier and propose a novel approach to drive the target feature towards the right side of the decision boundary of the fixed classifier. We refer to our method as BAIT. It can improve any compatible existing UDA method under source-blind setting. Here are the experiment's results. SB means source-blind setting. With our proposed BAIT, we can achieve state-of-the-art performance even without access to source data. In the future, we will further dive into the source-blind setting combined with other settings such as universal domain adaptation. The main challenge here is that without supervision from labeled data, the ability of feature extractor may be impaired. We need to find a solution for this.